Hello everyone, welcome to another video on my YouTube channel Code and Canvas, and in this video we are going to cover parsers. So we have around 14 to 15 parsers. I will be starting with the simple ones and we will be moving to more complex parsers in the further video. So in this video I am going to cover some basic parsers. So let's start. So here I am just loading my environment variables as we have done always from my environment, the API key. Now you are already aware of the string output parser. So if you have watched my previous video, you already know that string output parser takes the raw LLM input and returns the output in a string format. There are no formatting, validations or a structure happens in this parser. So here, just to revise, I'll just remove this part from the chain. I'm assuming you are already aware of this chain. This is a simple chain, and let me run it for you to get the output. So as you can see, initially LangChain returns you an object which has a content which contains your answer in a string and other metadata as well. So string output parser does nothing. It just takes this as an input and returns you whatever is there in the content. That's all. So if I just put string output parser back and run it again, now you can see whatever was there in the content, it's coming back as output, and all the other additional metadata and fields are gone. So it's a simple parser taking that and returning you the content out of it. Now let's move to the next parser, which is comma-separated list output parser. So comma-separated list output parser does whatever its name is saying. It's similar to its naming. So it returns you the input in a comma-separated list in Python. So the initialization of this parser is very similar, like a string output parser. You just initiate the object by calling it, and then you create a prompt and add this parser instructions in this prompt. So as you know, in the string output parser, you just created the object, right? And you just pass it in the chain, because whatever input is coming from the LLM is getting passed to the string output parser, and it's just returning you the output in string. But here, as you can see, while creating the prompt, you are passing some special format instructions in this particular field. So your prompt template is list 5 background technologies, and then you have something called format instructions, right, which you didn't have in the string output parser. So this we need because LLM by default returns you the output in string format. So if you want your LLM to return the output in some specific format or some in other format, you need to specify it explicitly to the LLM. Otherwise it will just give you the default output. So with comma-separated list output parser, as it's deviating from the default output of LLM, for this parser we need to pass some format instructions that are already predefined inside this parser and as written as a function of get format instructions. So let's see what this parser is doing. This is our template. This is obviously a variable which is we are all partially filling using this partial variable field. I have already explained this field in my video on prompts. You can just watch that out to understand what it does. It basically fills your variable, whatever variable you have provided, and whatever variable values you are providing here, it already pre-fills those variable inside your prompt, and other variables you can pass while invoking the prompt. So let's observe. As you can see, when I am printing the instructions that are being returned by this parser, comma-separated list output parser, you can see it's adding this to your prompt. So your prompt becomes list 5 backend technologies /n, and your response should be a list of comma-separated values. Example, foo, bar, bez, or foo, bar, bez. So it just tells the LLM along with your prompt that output should be a comma-separated list with some examples. Now if you run this parser using a simple chain like a prompt LLM parser, you can see the output is a comma-separated list of Python. So let's do one thing. Let's try to run this prompt without this comma-separated output parser. Let's compare the output with that. So I will be going to remove this part from here, and then I will be removing this part from here, and I'll just name it to prompt2. I'll just pass this prompt to prompt to here, and then I'll run this function again. Let me do that. Yep. So as you can see, as I'm returning the parser, it's not returning me just the backend technology's name. It's returning me the whole string. As my chain still has parser, right? It doesn't in the prompt. It doesn't give the specific instruction, but I'm passing the parser in my chain. But as you can see, the response that is coming from LLM is different. So if I remove this parser, let's look into the raw response coming from the LLM. Let me execute this again. Yeah, so as you can see, the response that is coming from LLM is like a huge strings. If you will see, apart from the name of the technology, it's telling us about them also. That Node.js allows you to build scalable network application. It's non-blocking and lots of other things, right? So that is why we want to send specific instructions to the LLM if we are using a parser that deviates from the default output from the LLM. So let me revert it back everything, and let's run this function again. So now as you can see, you're just getting the names of the technologies in a Python list. So that's what this comma-separated list output parser does for you. Now let's move to another datetime output parser. So datetime output parser is a parser that retrieves a date from a prompt for you. So for example, you have a prompt here. You are importing the datetime output parser from LangChain.outputParser. In datetime output parser, you can specify the format in which you want your date output from the parser. So there are different types of formats that you can pass. I am passing here to return me a year, month, day, and hours and minutes. So after you have created your datetime output parser, you do the same. You have a prompt. For example, you are an assistant that extracts deadlines from the text below. Identify the exact date and time. If no time zone is mentioned, assume UTC. Then you have your input text. Then again, like similar to comma-separated output parser, you have your format instructions, which you pass as a format partial variable by using this parser.getFormat instructions. So let's see what this parser adds to your prompt. If I print it out and if I run this function again, so you can see the parser is adding, write a datetime string that matches the following pattern. So whatever pattern you are providing here, it's asking LLM to return the output in the same format. And also it's also giving some examples for few short prompting like this, and return only this string, no other words. So it's asking LLM to just return the date as the output and nothing else. So that's how it instructs LLM to return whatever a user needs. So when invoking this this function along with this parser, this chain along with the parser, you can see the output to LLM is just the date, a datetime.datetime. So basically the output is just a string. It went to this datetime output parser and it returns you an object of datetime.datetime. So let's see, the prompt is here. I'll just remove the parser from this chain and I'll just run this function again. So as you can see, the content is string in braces, right? The content is string. This content is being passed to the datetime output parser. Datetime output parser gets this content from the content and it returns your datetime object by converting it to datetime object. So let's add it again and run it again. Let me trigger this method. Yeah, it returns your datetime object. Now let's move to another type of parser, which is EnumOutputParser. Let me just copy this here as well. So EnumOutputParser is a parser that forces the LLM to return only one value from a predefined set of allowed choices. So this is useful in case of classification system, routing logic, moderation system, decision engines, and ticket prioritization. Things where you want output from a particular category. For example, classification system. You want to classify a text into something that you have already predefined. For example, a review system, positive, negative, neutral. Routing logic, like based on some category or something, you want to route to different codings, right? Like if this is the output is this, then go there, output is this, go there, and things like that. You can just work with EnumOutputParser. So let's see how it works. So you have created an enum out of here, which has different ticket priorities as low, medium, high, and critical. Similarly, the same way that we have done with other parser, we are initializing the EnumOutputParser, and we are providing what enum values we are supporting in our EnumOutputParser. Similarly, we are creating a prompt which has a prompt description, which is classify the customer, supporting ticket priority, return only one of the following values. And then again, the same format instructions that are going to be the parser, that are going to be filled by parser. Then we have our input as a ticket. Now let me print the format instructions written by this parser as well. So if you will see, this parser specifically add this particular thing into your prompt. Select one of the following options as low, medium, high, and critical. So as we have provided 4 options, which we have passed in our parser as well, low, medium, high, and critical, it's asking LLM to return out of these options only. So when you execute this parser in the chain, LLM outputs goes to it, and the parser returns you enum ticket priority with the ticket priority enum with the particular value of it. So here, whatever string is written by the LLM, it goes into the parser as an input as part of the chain. Parser converts that into your type class. Converts this into your class, that is, you are passing in the parser and giving the output, giving it as an output. Now, without enum parser, output could be something like this. For example, let me remove this parser from LLM, and let's see. We are still passing get format instruction. We are still passing the instructions written by the parser in the prompt. So I'm hoping the output will still be one of these values, but it will be in string format, not in this class format. So as you can see, the content is always a string format, and it is critical, right? So now, as you can see, the class is LangChain core message.ai message. It's not your ticket priority enum. So that is what this parser is doing. It's taking the string output from LLM and it's converting into the class that you are passing into the EnumOutputParser. So with the EnumOutputParser, you don't have to worry about that output could be something else. You don't have to typecast it on your own. You can just do something like this. If the result is this, then do this, else do this. The next parser is RegexParser. RegexParser extracts structured field according to a regular expression. So they are useful when the output format is fixed, working with legacy systems, parsing logs, extracting predictable text. But they are very fragile, breaks easily, and less reliable. Let's understand this in detail. So you initialize the regex parser similar as other parsers. So you provide a regex here. As the name suggests, you provide a regex here, which is that it wants output in this particular regular expression format, which is service, anything, then slash and status, anything, then priority, and anything. So these regular expressions, they are basically accepting anything inside status, service, and priority, and output keys are service, status, and priority. So we are expecting 3 keys: service, status, and priority, and the value could be anything. Now we have a prompt. Analyze the system log, return output exactly in this particular format, which is service, status, priority, service name, status, priority. So whatever we want in the output, we are suggesting LLM to return the output in that particular manner. We want the output to match our regular expression, right? Which is like service colon any service name, then in the next line status, any status, then in the next line priority and any priority. So that is why we are telling LLM to return the output in a similar manner that we are expecting for our regular expression parser. Then we have a log as an input. Now if I do the same thing, let's try it out. Yep, not implemented error. So as you can see, this is not working for regular expression parser. because regular expression is not adding any kind of instruction to your prompt. You have to specifically ask in your prompt how you want your output to be written so that it matches your regular expression. Regular expression parser just verifies that whatever is getting written is matching the expression provided in it as an input. It does nothing else. That is why this kind of parser is like fragile, because if LLM returns something else that is not up to the mark, it will break your program. So same thing, I forgot to mention, but same thing will happen with the string output parser. In a string output parser as well, you notice that we are not passing it as a format instructions, right? So if I comment it out and run this function, you can see the same error we are getting, that this particular function is not implemented in string output parser. Because here as well, we don't want to give any instructions to the LLM. LLM by default returns output in a string, which is sufficient for this particular parser. So string output parser and the regex parser, they don't provide any specific instructions. You have to handle that in your prompt. If LLM provides the output in a same manner, in the similar structure, then good for it. Otherwise, this particular parser will break your program. So let me run it again. So these are some examples I have written to make you understand why this could be very fragile. So example, initially we are assuming that the expected output would be something like this: name, payment API, priority, high. But LLM can change the output a bit, right? Like it's not always fixed. So maybe instead of a name, it's returning a service name, or extra space between name and column, and then maybe a different order, the name below, priority on the top. So if any small change that is done by the LLM will break your parser, and that is why it's fragile and it's not usually used in the output. Instead of this parser, more advanced parser are used, which will be look in the next video. So the last parser for this video is MarkdownListOutputParser. MarkdownListOutputParser, this parser, it converts Markdown bullet list into the Python list. So basically, in your prompt, we are asking create a step-by-step learning roadmap for a particular input topic and return the response as a Markdown bullet list. So let's do the same thing here and execute it. Yeah. So if we do not pass this as well, we can do the same thing. We can just pass these get format instructions written by the Markdown list parser in the prompt. So two things: either you use these get format instructions from the parser and pass those instructions to the prompt by a variable, or you can do it on your own. Both things will work. All the parsers, they are just accepting the response in a particular format, and if they don't get it, they fail. So here, apart from the get format instructions is implemented in my in this particular parser, I'm not passing this as a variable. I'm just returning explicitly that return the response of the Markdown bullet list, because this parser also does similar. Your response should be a Markdown list, example this. Now after the response is fine, let me change it. So right now we are getting this response. Understand, without these instructions we are getting the response like this. Understand the purpose and importance of LangChain in the NLP ecosystem. Familiarize this, like a long description, right? Doesn't look like a name. Let me check if I pass these type of instructions into my prompt, then how do we get the response? Let me just copy paste and put it here instead of using the variable. Let's try to run it again. Yep, now we are getting the output as something like this: introduction to LangChain, what is LangChain, overview of its application and use cases, like a topic wise, right? A bit more clear response, if I think. So that's why it's easy to get whatever instructions the parser are providing from this function, add it to your prompt by using a variable, because these instructions are already tested by LangChain. They have created these by various rigorous testing and everything, so you don't have to play with the wordings or edit your prompt if your response is not correct. They will be crisp and clear. So it's always better to use the instructions if your parser is returning instructions that needs to be added in a prompt by this particular function. Okay, I hope all these basic parsers are clear to you. I will be ending this video now, and we will cover two very important parsers in our next video, which is pedantic output parser and JSON output parser. We will then compare why these two parsers are better than this regex output parser, and why regex output parser, how they handle things that regex output parser cannot do. So until next time, good luck. Keep practicing, and please like, share, and subscribe.